Good morning, good afternoon, or good evening. My name is Anthony, and on behalf of my co authors, Venera and Christian, I will be presenting details of our tool, Ideal, an open source identifier name appraisal tool. First, let's look at why high quality identifier names are essential in software maintenance. Developers must comprehend the code that they will maintain, meaning that the code must be legible and reasonably self descriptive. With identifier names accounting for, on average, almost 70% of the characters in a software system's code base, developers need to utilize high-quality names for identifiers. Hence, as a starting point for our work, we chose to implement the detection of linguistic anti-patterns in source code. We selected anti-patterns since they are well researched and they represent real, tangible identifier naming problems. Our work aims to provide the community with a single multi-programming language supported tool to detect multiple types of violations in identifier names. Furthermore, by releasing this tool as open source, developers can extend the tool to support additional name violation types in the future. At present, Ideal can detect 19 different types of naming violations occurring in multiple types of identifiers. Shown here are the 19 naming violation types. Most of these types are known as linguistic anti-patterns and have been defined and utilized in prior studies. Please refer to our paper or website for details around the detection logic for each type. Shown here are some naming violations detected by Ideal. Ideal analyzes both unit test and non-test files for issues. Ideal detects naming issues in method, variable, and parameter names. For example, in the set method return type, Ideal checks if a method name that starts with the term set has a return value. And if such an instance exists, Ideal marks it as a violation. As previously mentioned, Ideal is an open source identifier name violation detection tool. As a command line tool, Ideal can run as a standalone executable to analyze C# and Java source code files for the existence of naming violations. The tool does not require human intervention once it begins execution, and hence, it can be integrated into an automated build process. The tool, code, and documentation are available on GitHub. Features of Ideal include the detection of 19 linguistic anti-patterns in Java and C# source code. Ideal checks for these anti-patterns in attribute, method, parameter, and variable names. To provide better detection accuracy, Ideal supports project-specific customizations. Furthermore, as a static analysis tool, Ideal can provide developers with details around the type of violations that their code exhibits. Architecturally, Ideal utilizes some well-known tools and libraries for natural language and static analysis processing, including NLTK, WordNet, Stanford Part-of-Speech Tagger, and SourceML. Finally, the source code for Ideal is publicly available, and we welcome extensions and improvements. To evaluate the performance of Ideal, we manually analyzed 2019 detected instances from 4 systems. Our analysis shows an average precision of 75.27%. We also compared the correctness of our tool against an existing tool. We observed instances where our tool outperformed the existing tool. In summary, Ideal effectively identifies a majority of identifier naming violations. Furthermore, the ability to support project-level customizations further improves its effectiveness. A breakdown of our validation results is available on our website. With regards to the applicability of our tool, developers can integrate Ideal into their development toolset and workflow, such as the build process. We envision the research community utilizing Ideal in studies around program comprehension, especially in an empirical setting. Finally, educators can utilize Ideal in a classroom environment to teach students about the importance of writing high quality and maintenance friendly code. For more details about our tool and research into identifier names, please visit our website scanl.org. Thank you.